All right, here's our centroid rules. So we're going to do some centroid math. We all know what this is. We have a rectangle over here, and we can divide those two up. And now those are the location points, and we can do summation of AI xi divided by summation of AI equal xc. I think it's called AC. Summation of AI yi divided by summation AI and equals YAC. Okay, it looks like from the view over here, YAC has more diversity, so just choosing that is easier. So we're going to choose the diversity one. So over here, we could do summation of, we could just say, do Y, right? YAC equals, what is this? Area, so it's 2 by 8 plus 12, about 12. So then we have 12x, so 12 by multiplied by, what is this? 5? Looks like it's 5. Plus 8 parentheses, just ignore it. 2 equal what? Let me get my calculator now. Because I need my calculator to solve this, because otherwise, you could look solving it. 12 multiplied by 5 plus 8 multiplied by 2 divided by 8 plus 12, which is about 3.8, which, yeah, that doesn't sound right. What's happening? I think there's a mistake on this one. Yeah, there's a mistake. Damn. When we imported this thing, apparently this is supposed to be 3.8, and they weren't for some reason it didn't show us 3.8, therefore it messed up. This is why I have the original question on me at all times because we know how messed up this import system is. Sometimes it doesn't import correctly, and you just have to really just deal with it. Um, yeah, 6, and this is actually 3.8. I did not make a mistake. Pretty sure I'm right. Okay, therefore, good job on that front. If you find other mistakes, please do tell me. I will fix them. Let's see. Okay, that was available. Yeah. Okay, next one. Isn't it the same question? What is the x and y coordinates of the centroid in question? Okay. Problem two. Did it import it correctly? Yeah, centroid. What are the x and y coordinates of the perimeter line? You're joking, right? You're talking about the perimeter line? Is that even some? Hey, I never knew that this existed, but sure, perimeter line. We can do that. I don't know why you would ever want to do this, but it's just basically probably um making sure to do this x summation I Li divided by L. Yeah, and I'm pretty sure you're just defining these points over here. Yeah, and again, less diversity here, so the most diverse is the Y. So delete this one and do the Y version because the Y version is better because there's more diversity. Oh, first of all, add up your lines so we can get L first, the summation of Li over here. So 4 plus 4 plus 2 plus minus 2, 2. So 6 minus 2 is 4, so 4. So it's 2, 2 plus 2 plus 2. So 4, 4, 2, 2 plus 2 plus 2 plus 6. Okay, I get 24. So this equals 24. And then you have to add up all the, wow. That's gonna be faint. 4 multiplied, I started with this one, 4 multiplied by 2, plus 4 multiplied by 2, plus 2 multiplied by, oh wait, this is y, right? So 0. So we did this one. And then this one over here is, it still applies, right? I think so. Yeah, probably does. Is there an easier way to do this? Probably. I just can't figure it out. Plus 2 multiplied by 4. Uh, multiplied by 2 again, because there's two of them. Ah, there's two of them, so we can actually speed run this by multiplying things by 2 again. So plus, not making that. 2 multiplied by 2 multiplied by 5 plus 6, right? So 6 multiplied by, what was it again? 6, enter, divided by 24 is 3 point something. I got 3.75, which is probably a rounding error, so I think it's C. Yeah, 2.7. Over here, what's the area of moment in the x-axis? Area of moment? Well, we have to look over here. Area of moment for a square is this, I believe, for centroid, right? Why is there like four of them? Well, Not really a big problem. I guess they just like to repeat themselves like 16 times. And then I'm pretty sure there's a parallel axis theorem we can run over here, which, yeah, plus AD basically is what we're doing. And about the x-axis. So what we can do is say do this over here, right? And do that way. Therefore, there doesn't need to be a plus AD, right? Um, or, but it might be asking directly from here. Then we need to do a plus AD over here, right? But is there a way? So in the viewpoint over here, there's actually something incredible that if you actually look over here, this is from this point, XC, YC. Over here is from the actual edge axis. So all you have to do for the first one, first blocks, is not even worry. Just grab your X from the axis, apparently. BH cubed divided by 3. What does that do for you? Something incredible. You get to skip all the pain and effort of doing plus AD over here. Isn't that awesome? So what does that do you? For HCAB, basically the bottom is the base, remember? Height is the height. That should give you the answer. So let me just plug it into my calculator real quick because, you know, always helpful. It's about 42.66 bar. So that's really incredible. Now we need to do a plus AD. Now here is the issue for the other one. The other one, it's not in the x-axis, so you have to actually do a plus AD. There's two ways to do it. I rather like when I do the F, E, G, D, I like saying equal to the 12 version plus AD because it doesn't confuse me, square. So that doesn't confuse me. And then we add HCAB plus FEGD to equal something. So this is obviously wrong. I think that was supposed to trick you. So that is clearly one of the wrong answers there. So I'm not sure if they were trying to trick you or not, but I think they were. Otherwise, they were just messing with you with different numbers, which not not sure if they were, but if they were, they were doing some job on it. So now we have to just do the other ones. So B is base. So what you have to do is basically B equals what is it, 6 divided by H, which is 2, and it's cubed divided by 12 plus 12 by D, which is 5 square parentheses. All right, 6 multiplied by 2 cubed 3 divided by 12 plus 12 multiplied by 5 square, which is 3 or 4. And then plus this equals D. It gave me 346.66. But remember, in FE exam, it's always round up to a second. So it is D. Wow, there's a lot of questions for just one of these. Um, this is going to moment of inertia about the x-axis. Yeah. And okay, so this one is the centroid moment of inertia with respect to the x-axis. So time we figured out somewhere over here that it was like the centroid from problem 1 was somewhere here, which the centroid is x centroid equals 3 cm and x centroid y centroid equals 3.8. So it's still, I don't like how they didn't put area of inertia. They should probably put down this area centroid of inertia, but it doesn't really matter. What you have to do now is with that knowledge, from wherever 3 is, from here, which is x3, it's probably here, and then 3.8 is about over here, so I was about right. You have to do plus AD square here and plus AD square over here from that centroid point. Nothing major. So is BH cubed divided by 12 plus AD from the centroid. Now, how we get the centroid distance, this is actually for y direction. So we needed to do the x direction. Oh, this is the x direction, my apologies. X direction. So uh honestly, we just have to figure this out, which if I remember correctly, for Pacific x direction, the moment inertia is on the y. It's kind of reverse, I call it reversed in a way, if I remember correctly. Let me look over here and see if that's true. You see over here is it's the parallax theorem. Here is the dy. So basically, it's the difference between whatever this point is, so that's 5, minus 3.8. And then to the plus BH cube 2. This is 1, 1. And 1 is the top T, bottom, I guess you can do that. 12 plus A parentheses, what was it again? It's over here, which is 2 minus 3.8. Square, square. So XC equal what? This thing over here. Let's just figure out what this is. So that is calculator on, divided by 6 multiplied by whatever H is, which is 2 cubed divided by 12 equals about 4. Over here is division. Is about base is 2 multiplied by 4 cubed. Wondering squared. Also, make sure you don't do squared. That's a really big problem I have here. So 10.66. Really? Oh, because H has more oomph to it. It makes sense. We do 4 plus area, which is 12, multiplied by parentheses, 5 minus 3.8 parentheses square, which is 21. 21 plus 10 plus whatever this is. This is A. A is 4 times 8. This is 8 multiplied by parentheses 2 minus 3.8 parentheses square equal 57.866. So I'm going to assume that the answer is B. Yeah, I hope that's right. Okay. Uh, Next up is a question involving the central polar equations. Looks like here it is, the polar equations. What is the centroid goal? Is it also the gyration rate? Okay, I'll be honest. The gyration, yeah, we can do it, but I really don't remember what the gyration actually means. I know how to do it, I just don't know what it means. So that's a scary part. So I might need to search that up later. I will search that up. The reason why is because the radius gyration. I remember being like imagining this for the axis. So. It's the radius of, yeah, we never really used it in class. We just did it one day and then was gone the next, I think. Well, we never even covered it. So this part over here, the radius of gyration is going to be really interesting when we do it. Anyway, either way, we are going to do centroid polar, which is what we call J. And how you get that J is basically, if I remember correctly, is something like IX plus IY or something. Just look it up. It's on the table, like somewhere on the table. I don't know where, but you can find it here, over here. Look here. Perfect. IZ equal IY plus IX, which is equal to J, which is equal to whatever this integral is, if I remember correctly, which is integral of x squared plus y squared dA. We won't need that integral for this question because this is an already given question. Now, this is going to be the centroid, so it's going to be looking at the YC coordinates and XC because it's asking for in the centroid, right? The y-axis passes to the centroid. Mm. So what we need to say here is that we just have to solve for it, and we're done. I'm gonna just take a page of my book and look back at here and just say that was 58. So J equal, one of them is 58, which is X. We just need a plus YC. What is YC? The centroid's over here, right? The 3. So we need to look at the centroid over here. In that case, it's all in the axis over here. So we can do YC equal B over H cubed divided by 12 plus B over top, 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 H bottom, 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 cubed divided by 12 equals something. So this over here, I don't remember what it equaled. And also it's actually different because, oh wait, I need to look over here. You flip those. I didn't flip them because I usually use memory, which means I just flip the bases. But actually, the better way to do it is do it this way, right? That way is better. So because then you keep the units to constant, right? So I do division and we do base. It doesn't matter how I ordered it in my calculator. So just plug it into your calculator and let me just do it right now. Base is 6 cubed, right? 6 cubed, right? And then 2 divided by 12. I get about, why is it not giving me anything? I get 38.6. So add those up, plus 58 equals about 96.66. So it's about C. Yep. So there's a few things you need to remember. So that's the answer. Oh, the gyration radius. Yeah, this is going to be doing this one over here. And what kind of gyration radius are you looking for? You're looking for the horizontal RX. So there's a few ways. The radius gyration is the distance to the reference area. That's concentration of the part of the term. So I guess um, you can use Rx like this, or just put Rx over here. Is it at the centroid or what? Passing through the centroid. So you could genuinely just do h cubed over here, square root of. Oh wait, no, you can't because over here this is doing. Sorry, this over here is doing one part. So you have to really do it two times over here. It's a pain in the ass. So instead of doing that, we're actually going to use this one over here because this is the same gyration over here. So you can use this Rx equals square root of Ix over A. And this should be the definition of gyroid. So if you put a C over here and C over here, you're getting a C. So did we get the definition of what is a centroid passing through? I think it's this one, right? It was B was 80. It was centroid with respect to the y-axis. No, that's not correct. We are looking at something. Where is it? Area. Let me. It's this one. Respect to x. Yeah, that is that one. Yeah, 58. Yeah. So we do that and we do Rxc equals square root of 58 divided by area, which is basically 12 plus 8. 58 divided by 12 plus 8 equals 1.7029. So that's B. So with that said, we are actually going to begin a little bit of the harder grinds over here. So this is what we call the reverse rule. So I like to call it that. So you have a summation over here that's basically saying AXI, right, divided by XI. There's something called negative area, and in this case, we're going to use that negative area to inform our choices. So basically, is what's happening here. Mathematically, we're creating negative area. Theoretically, no. What that means is basically if the whole net total is negative, we fucked up. No, no, net total is negative is fine because you put the order. But if the area total, if I do area total and this area total is a negative, then we fucked up. But what we can do is do this. Area total over here is equal to, what's this? 10 multiplied by 8 minus radius of 4 square pi. That's the radius of a circle. And then 2 times 2. And the same vein, you can do 10, 8 by the centroid, which is the middle over here, which is going to be 4 minus 4 squared pi, and you can find that 5 minus 2 times 2, parentheses, where's the other one? This one is 1, and then it's going to be plus 2, which is 1, so it's 2. So you can see that this is a possible equation. And let me just grab my handy-dandy calculator and calculate all of this. My apologies, it's a diameter, so this is a 2 over here, this is a 2 over here, so there's that. So in that sense, you just have to divide by 2 over here. Okay. What? All right. And divide by 2 over here. Make sure you double check your math because sometimes that does happen to me where I read something and it's a diameter when it should be, perimeter, Anyways, let me get the last version of it where we do 2 over here. And then we do this divided by this, which I get 3.9 through 28013 if I do this. So it's like 10, 8 minus 4 divided by 2 square pi minus 4, and let's just do parentheses here, and I get the answer as C. Because the other one is baloney because they have weird answers and they're not correct. So we can move on with the answer C. Next one. Assume the centroid, I can barely read that. Bigger. Assume that the centroid moment of inertia area A2 with respect to the composite, okay. Composite centroid x-axis is 73.94. Assume that the moment of inertia what is that? I'm assuming it means A3. With respect to the composite x-axis is 32.45. What is the moment of inertia of the entire composite area with respect to the central axis? Okay. So this is trying to figure out basically what's the moment of inertia of the entire composite area with respect to the. Oh, this is a dumb question. I don't know why they do this to you. Um, why they? I mean, oh, I see what they're trying to do. They're trying to make your life easier and harder at the same time, I guess. But all right, what is A2? A2 is that. So what it's saying is basically be lazy. Um, so this is getting inertial A2 to the composite centroid of what to say x-axis is this. So basically this is saying that over here AXC of area 2 equals 73.94. AXCA3, which is this one, equals 32.47. So what we can do is get the total moment of inertia, and they're asking for the entire composite area. So again, this is called, I mean, it's really called superposition, but it's just adding things and minusing things. So these are actually considered negative moment of area inertia. So what we can do is composite over here is equal to H3, no, B is, this is X, so B H3 divided by 3. We discussed that last time. Minus 73.94 minus 32.47 should give you the answer. That's weirdly phrased, I must admit. Did not like the phrasing of it at all, actually. 3 divided by 3 minus 73 minus 32. But then again, when has they ever, right? Did I mess up the height calculation over here? I'm getting something that's insane. So that's clearly not the answer that they were looking for. Uh, oh, I'm dumb. They're probably just looking for this 12. And then with that said, we also need to figure out what the centroid is not in the center, although. Yeah, the centroid is not in the center. Oh, I have to figure out the centroid first, actually. And the centroid is found by this kind of formula, but we have to find YC over here, which we figured out over here. Ah, I see. That's why it's a two-part question. My apologies. I did something pretty bad. Uh, so let me just delete this and do x equal 3.93 and y equal 4.79 and the cm. What does that mean? Well, basically, we have to do, so this 5 centimeters, right? Actually, theoretically, it might not make, oh no, so the answer choices are very close by. So what we have to do is basically say I of the total box without minusing anything. We'll subtract later on. I can see now why this question is a little hard. B3 divided by 2 and y is 2 parts plus a parentheses is going to be 5 minus what the centroid is, which is 4 point, and this is x direction. You might be watching, that makes sense, right? 6.79 squared. Barely anything, but that will make a difference. Apparently, I'm going to my calculator. 8 multiplied by h, which is 10, to the power of 3, divided by 12. I don't know why I got 3 down there. Plus 80, parentheses 5 minus y I thought was 3 I meant earlier. And then that equals about the 670. And I box x c, this is c by the way, minus whatever this was. Where was the other one? 73 minus 32 should give you the answer. Minus 73 minus 32 should give me 565. I'm thinking it's just round down to D. I think D might be the answer. And we'll be moving on right now because I think it's just a rounding mistake I found. Uh, I got 565, but I think it's just they just round down maybe, or maybe I just did a rounding error that caused a little bit of mistake here and there. But either way, it is D. Next one, the segment coordinate is what is the centroid of wire? Well, that's simple. We just have to do the summation of L by xi divided by L total. So this is equivalent to saying 12 plus 10, and then 12 parentheses, you need, this is going to be in which direction you want? Y, AXC then? Maybe? Yeah, let's do that. So the 10 is easier because it's 5, right? Over here, you have to do something like a 12 cosine. No, not cosine. Sine. Sine 30, okay? And divide by 2, which equals, I don't know, 30 divided by 2, which is 3. So I get something like 12 multiplied by 3 plus 10 multiplied by 5. Oh, I just deleted my own entire thing. 10 multiplied by 5. There's something wrong here. I think it's negative over here, right? Because of how it's phrased, it needs to have a negative over here. I will just do that again. Multiplied by 3 plus 10 multiplied by 5 divided by 12 plus 10. You can speak, you can fast forward, right? So it shouldn't matter. Yeah, and that should theoretically give you the answer. Yeah, yeah, that should give you the answer. I don't understand why it's not matching. Oh, it does. It is B. Okay, I got this equal to this is 3. 0.636 something, and I was like, none of them match, but 0.64 is rounded up again. So it's B. Okay. So I'd say none of this makes sense, but yeah, it does make sense. It's just rounded up. Okay, we do the next one. Okay, the moment of inertia of a y-axis of cross-section is x-axis at what's x pi? Oh, what a weird question. So this is x pi apparently. Shown So moment inertia at x pi equals 245,833 cm4. If the cross-section area is 25 area, so this area is 250, and the thickness of the web and the fang are the same, what is the moment of inertia about the centroid axis? Um, this is basically the idea of basically using none of the thicknesses matter. It's just trying to figure out if you know the parallel axis theorem, I think, because x pi equals xc plus AD. If the area is 250 square, sorry, and then this over here is d, where's d? D is the distance, so it's the 30 square. If I were to do x prime minus 250 multiplied by 30, let's just do algebra the notion way, because if I do it algebra the notion way, then it's universal, equal AC. So therefore, I can plug in 245 point, this is a point, I'm pretty sure. If it's not, it's not. That's a huge number. 33, 833. Minus 250 multiplied by 30 square equals 20811, which is this one, A. I'm pretty sure it's A. You can double check it later. I'm pretty sure it's A. So next one, the structure is shown to form of three separate solids, aluminum, cylinder rods, each with diameter 1 centimeters with the z coordinates of the center volume for the structure. Okay, so what is a z co what is a z co what is that makes no sense. That's just what 0.5. Let me look at the original question real quick. Oh, yeah, that makes more sense. So apparently they have miswritten this one too. This doesn't make sense at all. Let me just put a new one over here. Transparent. Over here, it's supposed to say with 6 in between and locked. It's supposed to say X. Yeah, I mean, half the time is just double checking you got the right wording down. So X coordinate of the centroid. Okay, so basically what's saying is we have, I mean, um, for the structure. Okay. So I'm pretty sure we can treat this as a line. There's no reason for me to treat this as nothing more than line segments. I think, personally, I would have just treated this as LXI divided by LI because we have a coordinate over here, we have a coordinate over here, and we have a coordinate over here. I don't see any reason for me to not treat it as a line. Um, if you can, that'd be wonderful, but I don't see any reason for me to go on my way and change this whole thing to that. Do you? Yeah. Let me read this one time. The structure shows formed a separate solid cylinder and 1 centimeter. So what is the x coordinate of the centroid of volume? Oh wait, we have to do the volume. Sorry, my apologies. That's not right. We're supposed to do VI xi divided by VI summation. So with that said, volume of a solid cylinder, or is it just a solid wad cylinder? Okay, so it's not hollow, there's no thickness, so thank God. And then we just have to do basically radius of 1, so it's 0.5, not radius, diameter. And then we just have to use this equation, which is pi r squared by height. So for each one, the volume is basically 26 over here. So 26 summation of VI equal 26 multiplied by pi multiplied by 0.5 squared plus 10 pi parentheses 0.5 squared parentheses plus 24 multiplied by pi 0.5 squared. Okay, we can get that down. This is 26 parentheses pi multiplied by 0.5 squared parentheses, right? And that I need to do 3 more times on my calculator plus 10 parentheses pi multiplied by 0.5 squared, okay, parentheses plus 24 parentheses pi multiplied by 0.5 squared parentheses this. So I get 74, 47 on the bottom. Um, yeah. So this I get 47 on the bottom. So now we have to do the top. And the top is a little harder. So because we have xi, we have to figure out the coordinates of this and multiply it. So instead it's like, let me erase this. I'm not sure if they will test you on this because why would they test you on this? 26 pi 0 0.5 squared parentheses by that's the 26 over here. So that's 26. We have to get the angle over here. We have to get the cosine of theta, which is equal to saying 10, no, 24 over 26. So 24 over 26 is the multiplied by 26 divided by 2, right? Am I correct? So 26, yeah, I think that's correct. I think that's how you're supposed to do it. Um, hopefully, I think 26, and then you divide by 2, then you get multiplication. It's supposed to say that, I think. Let me double check that although, because it's 24 cosine, so you just move, yeah, right? Because you did this over here, and this over here is 13, and you divide it. Yeah, that's correct. Okay, we're good. Now we do that plus our, once again, 10 parentheses pi parentheses 0 0.5 squared parentheses, what was it, 10? So it was at 24 plus the half of that. So it's 13 next, until 12 next, sorry. And then it's 24 multiplied by pi 0 0.5 squared parentheses. Okay, let me plug that into my calculator and figure things out. So we know it's 26 parentheses pi multiplied by 0 0.5 squared parentheses, right? Multiplied by some ridiculous division of 24 divided by 26, multiplied by 26 divided by 2, and then we add over here, but we can just do this first, which I can get that number. And then we can do plus 10, right? Parentheses pi multiplied by 0 0.5 squared, parentheses 10 pi, and then multiplied by, what is it, 24? Okay. Plus is going to be 12 about, multiplied by 24, multiplied by parentheses pi, multiplied by 0 0.5. There's a real possibility I made a mistake here. Uh, okay, I get that. Divided by the long answer here, divided by 47 or something. I get 14. I get exactly 14.0 when you plug that in. So it's A. I get exactly 14. So that's impressive. I like this question now. Very, very, very cool. What is the polar moment of inertia about the composite? So this is polar again. So we go over here. Polar is this. So again, it is J equal IY plus IX, but we're going to go for CCC, right? That's what they're asking for over here. They're saying what's the mo polar moment at the centroid. So obviously the centroid is going to be over here. I mean, no doubt about it. And then we can get over here. Circle, where's the circle? Oh, wait a second. We have this over here. We have this. We have a shortcut. J equal pi A4 divided by 2. A beautiful shortcut. Can we use that to our advantage with the parallel axis theorem? Does it work with I genuinely have no idea because I've never tried it before, I don't think, in the class. So it's gonna be new for me too. So I think it should. It should just be getting the area and probably doing d squared to it because it's always been the case in whenever I do it with other equations. So I'm just gonna assume that the parallax theorem works. So for a circle, this is right. So this is actually pi r4 divided by 2 because r is what? 4. So pi 4 parentheses to the 4 power divided by 2. That's wonderful. Anyways, okay, so here's the thing. I think this is good. This is great, but I'm not sure if the parallel axis theorem actually, because you need area times r, so parallel axis theorem works. I think it'll work. I don't really know if it'll work, but I'm pretty sure if my brain is saying it correctly, it would work. You just have to be a little bit careful because I think you have x and y will be different because there's no parallel for x over here, so we don't have to care about x, but there will be a parallel for y direction, right? So yeah, because let me check over here. 5 pi a like that. Well, that's not really right. Let's see. A pi 4. Okay. So what we're gonna do is basically do this. I think I have an idea. So we're going to use J equal AXC plus AYC because I think that's easier. Because I think the parallax theorem doesn't, it's not just J plus, you can't just do J plus a pi, area times D squared. That doesn't seem right. I think it's specific to the region you're looking for. So that means I think to be absolutely sure, I don't really know if it's true, but to be fair with you, uh, we also have this form over here. So we can actually use 5 pi a squared divided by 2 for moment of inertia in the x direction. So we can shortcut a little bit of it because we already have it. So that's multiplied by 2. So we have that in our disposal, right? Yeah. With that said, we can do that. I think is 4, but let's multiply by 2. So it's 5 pi a squared if you're wondering. That's I shortcutted it a little bit, but now I show the steps. So if you're wondering, equal because of two of them. And then the other one is pi a. It should be to the fourth, isn't it? Yeah, it's 4. Sorry, this is to the 4. This is to the 4, and then this over here is 4. So it's 5 pi r squared divided by 2 plus pi a 4, sorry, 4 divided by 4 equal j. So if you do that, you should get the answer, I think. Where's pi? Pi 4 to the power of 4 divided by 2, I think, plus division pi multiplied by 4 to the 4th power divided by 4 equals what? I get 704 pi. So let's just simplify to this. It's 2020. That's not none of the answers. What's going on? Oh, I made a mistake here. I think this is 2, right? This is 2, right? 2, so this is 2. Sorry. That's a mistake I made. Because there's two of them, obviously. I don't know why I did that. So it is 2412.7. So it's obviously D. I'm just gonna give that the out and move on to the next question. The polar so we have the answer J equal 2412.74. Polar radius of gyration. There must be this. Here. So it is square root of 2412.74 divided by area. Area is pi 4 square, and there's two of them, so 2 equal that, r. So I still don't know what it means to have a gyration yet. I'll search it up. It's probably one of those gyrations you have, in the space station. So pi 4 squared, parentheses equal. I have 4.8. I get 4.898, which is 4.9. Wonderful. That is D. So we have that. Okay. All right, this one over here, we're doing a moment of an okay, the area is you figure out first of all the diameters over here, which is helpful. And then we cut something like a little bit over here. Both circles are tangent. What is the moment of inertia about the y-axis? Okay, the remaining shaded area. So this over here is important. So we are going for I, y, because this is I, y direction. So here's the thing. This is two circles, so we don't even have to think. We can go over here, go to two circles. Over here, we have I, y over here, which is pi a 5 pi a4 divided by 4 because we're doing it at the axis point and they're all the same. So what we have to do is 5 pi a4 divided by 4 minus 5 pi a2 divided by 4 equal whatever it is. So let's just do that. 5 pi, and then it's going to be 28 first. 28 by the power of 4 multiplied by 4 minus divided by 5 pi multiplied by 22, 21, square to the 4, and 4. Okay, I get a huge number. That seems to be something. It should really be the answer. Why is it not? I get something big. Did I make a mistake? No, 21, 28, 21. Oh, I forgot to divide by 2. My apologies. Basically, is 28 divided by 2, which is 14, and 21 divided by 2, which is about 10. I'm not gonna do a lot of okay, so it's about approximately 1,11589. There's 4. Okay. That is about B, I think. Yeah. What happened here is basically I rounded this up to 10. Let me not round this up to 10 real quick and see if I get the same answer because clearly rounding up was a mistake. Um, 21 divided by 2 by parentheses to the fourth power. Syntax error because I forgot the 4 on the bottom. Okay, in that case, if I don't round this up, I get to 103,126. So that is about B again. So either way, you could have got the answer. I should have not simplified there. Don't simplify apparently. That does flip you over a little bit. Over here, we're doing what is the x coordinate of a centroid of the area under the curve y equal cosine. Okay. We are trying to do y-axis, right? So we're doing x, y, c. We're not even doing c actually. We're just doing y, c. So we're just going to do what we call area integral over here, which is going to be dA. And over here, we're going to integral y dA equal. That's it. So integral from 0 to pi over 2 of cosine of x dx is equal to a, right? That's the area, right? So on the top, wait, I think this is wrong. My apologies. I think this is actually x. Do I remember correctly? That is, let me double check. Um, yeah. Always remember that is the opposite, opposite, opposite. Like this is opposite. Wait, no, it's not. It is y. No, I was right the first time. It's a centroid, not the moment of inertia. I apologize. I was right the first time. Y and oh, I am fucking. What am I listening to? Michael Jackson? This is x axis, so this is x AC. My apologies. This is supposed to be x and then dA. Okay, so I don't know what my brain was thinking. Anyway, 0 to pi over 2 x the cosine x dx is equivalent to saying integral x dA in this case. Yeah. So grab your calculator and there's like integral function probably in your calculator and do 0 to pi over 2. And the inside over here is about a cosine. You can check your own sign convention, but it should be obvious what you're doing. It should be x cosine x. If you're asking where, if you don't have something like this, you have to do it by hand. But most calculators now, even your non-graphing calculator has it. This is my non-graphing calculator that's allowed by the school, and it does have it. So I'm pretty sure, confident almost, that you guys have it too. Okay, I get 0.785 as my answer. So with that said, let's just go down. And if you're asking me how in the world did I do that without doing math, over here, bro, there's a whole entire way to do it over here. And you can see over here how you do it. This is a second over here to that. And in modern days, there's absolutely no need to do an integral by hand usually. There's always numerics to solve it for you. And numeric calculators. So you don't even need to be knowledgeable of how to create those numeric calculators anymore because they're already made. And it's basically just do it now. Okay, interesting. I don't get any of the answer keys right now. Did I mess up the integral calculation? Probably did. Uh, x, maybe I did put the parentheses on one of them. I think that probably is right. Oh, I think I didn't put cosine in here. For some reason, I put some weird x parentheses. Huh. So for some reason, it's actually flipping me that's not the right answer. I am confused why it's not working. It should be working, but I'm getting none of the answers, so hmm. I can do it by hand, but I don't really want to. I'm trying to make my calculator do it. Oh, it's in degrees, bruh. Let's go to mode and go to radians for a second. Also make sure your calculator is in radians, bruh. Okay. That was embarrassing. You can see now it's in radians, therefore it gets the right answer. And that's B. That is B. So it's B. Yeah. Make sure for I didn't know this actually. For your even in the integral format, you need to make it in radians. Otherwise, your calculator doesn't work apparently. Anyways, we move on to here. X centroid. We do the same thing over here with the centroid. We know what to do at this point, hopefully. X AC equals summation of area over xi divided by summation I. Fun fact, index notation would have saved you a little bit. You would do it in this format if it were index notation, because that's a dot product, and this over here, down over here, will be square root of AI, which is interesting. I mean, just to be fair, that's no, that wouldn't be. Yeah, that's not right. Yeah, that's not right. I think for the summation of this one, you keep it like this. But yeah, that is I just realized this is actually a dot product then. Huh. With a summation on the bottom. Interesting. So you could write this as a dot product. Interesting. Because now I'm interested because I get to use index notation again here, which, beautiful enough. We will stop doing that right now and go to here. So over here, we know that we could split this into like this one, possibly split it in half over here if depends on what they give you here. Yeah, you have to split in half. No doubt about it, because you're given this one over here. So you're given the top You're given the box, and you're given this. Now you're gonna add a negative I moment over here. This is gonna be the negative one. Now, again, it's a very interesting concept to have a negative version, but it is true and it works. So with that said, let's calculate this. So we know that first of all, we need to get the area of the bottom. So summation of the area, let's just do a summation of the area over here divided by summation of AIXI. So 5 times 1.5 plus 3 times, what is the distance in between? Do they even give you the distance in between? I don't think they do. They don't, but I guess you can assume it's 6 because it's this thing again. So 6 plus 3 square pi over 2 because I divide by 2 because half was here minus, and it's going to be pi 1 square because there's an in-between inside that has like a pi. So we have solved it. We have gotten all the information on the bottom to get the area. And then we can do 15.1.5 parentheses, where's the distance, which is 5 divided by 2 plus 6, which is where? 3 divided by 2, assuming we're doing the x direction, which is the y direction matters, plus, wait, I think I do this wrong. X direction matters. This is doing, sorry, my apologies again. This is not doing y. Oh, I am flipping here. So this 1.5 divided by 2, 3 by 6, that's 6, that's 3. And then the last few are 3 pi squared over 2, 3 plus pi 1 squared over 3, which this is minus also, which means you get this answer over here. And I'm feeling that this is going to be a long one because it's going to have multiple parts to it. Let me just do the math now because I think we got it right. Unless I messed up somewhere. I don't think so. No, I don't think so. So let's just do it. Let's just grab our calculators and do it. All right, let's go to the bottom first. 7 multiplied by 1.5 plus 3 multiplied by 6 plus division. 3 squared pi divided by 2 minus pi. Enter equals 36. So the bottom is about 36.495 something, which I'm just going to simplify it to 5. It's going to be easier. All right, and then the top portion next. 5 multiplied by 1.5 multiplied by parentheses is 1.5 divided by 2. All right, plus 3 times 6 multiplied by 3 plus division 3 multiplied by pi. The squared? What's going on here? Oh, it's 3 squared, and I just mistyped it in there. Divide by 2 multiplied by 3 plus, no, minus pi multiplied by 3. Okay, I get 92.611722286, which equals what? Divided by 36.5 is 2.537, so 2.54 B. Okay. What's the y coordinates? We do the same thing. Summation of yi divided by summation of you don't mind if I do it like this, right? You don't mind if I call it like y dot a divided by summation of a, right? Because it is the same. Anyways, so last time what did we get for the bottom? It's 36.5, right? We got that. Yeah, we got 36.5, so we're just going to continue calling it 36.5, and then we're just going to reference the same area coefficient. So let me just look at my calculator and how I did it. So 5 multiplied by 1.5, right? Multiplied by 5 divided by 2, plus 3 multiplied by 6 by uh 8 divided 8, no, 5 plus 1.5. Oh, this multiplication looks like addition, so I'm just going to do parentheses on multiplication. At least that way it just more visibly makes sense. Anyway, plus what is it? It was 3 squared pi over 2 multiplied by, what was it again? Multiplied by, actually, we have to use this over here to figure it out. So this shows you over here that y is 4a. So 4, 3 multiplied by 3 pi. Okay? Yeah, so I realized what the mistake is over here. This is not correct. You're supposed to do 8 plus 4, 3 over 3 pi. That's the mistake I made. Yeah, that was took forever. I was getting none of the answers, so I was like, there was something wrong I did, and I forgot to do that. Well, that happens to everyone. 8 plus division 4 pi, well, 4, 8, 4 multiplied by 3, about 3 pi, parentheses, and then we do minus 8 pi, which gets you 241.7, 36.5. There we go. So division 36.5 equal 6.6223. So that's D. There we go. All right, we have D now. What's the next one? What is a moment inertia in about the x-axis? Okay, so we do the x-axis over here, and we do moment of inertia. So moment of inertia on the x-axis is basically doing all of that again. Yeah, okay, we'll do it. I mean, I don't think there's an easier way than just do it. Like, maybe you can have a better way, but my well, unless there's a yeah, no, you just got to do it. And I'm guessing it's a lot of parallax theorem over here. Yeah, pretty much a bunch of parallax theorem. Why are we doing the centroid though? What is the gyration? Okay, all right. So we're not doing the centroid apparently. So we're just doing moment inertia. Okay, so I thought that would be more part of this question. I guess it's not. So in this case, we need to do region this. So we have to region this like this. There's like three regions again. There's three regions again. And then what you have to do is first of all 12, and then this is the x-axis of B, H. I believe it is x3. Plus AD square because you're doing it over here. So you're going to have an AD square. That's region 1. So whatever this is. So we'll just do that right now. Base is 1.5 multiplied by height, which is 5 to the cube power, multiply divide by 12 plus 5 multiplied by 1.5 multiplied by the distance, which is 2.5 squared equals about 62.5. I think that is right. We do region 2 next, which is this over here, which is again bh cubed divided by 12 plus ad squared, which is this time it is division of 6 multiplied by h is 3, and it's a cube, divided by 12, plus area, which is 18, multiplied by distance, which is 5, plus 1.5 parentheses to the square, which is about 774, which kind of makes sense. That doesn't sound right. I think I made a mistake here. Did I choose the right x? I chose x at that point, yeah. Divided by 8 pi to the 4th power, yeah, that's correct. So maybe you're not supposed to use that formation. Uh, maybe it causes a little bit more problems than I thought, but I doubt it. It is pi. Okay, just recheck my calculator. So over here, we're not going to do this way apparently because it's for some reason doesn't give me the right answer. We tried it earlier. Anyways, we're going to instead do I5 9 pi square minus 64 divided by 72 pi, and then we're going to do plus a by a distance of a plus, what was again, 4a divided by 3 pi square instead, which that gives the right answer apparently. Okay, so if you plug in the calculator, get 8 plus area, which is um, pi multiplied by 3 square divided by 2, parentheses, multiple, parentheses, 8 plus division, 4 multiplied by 3 divided by 3 pi, and then we do parentheses square. And you get 1, 2, 4.587831. Okay, and that's how you do it. Okay, now we have one last one, region 4, which is basically the last region is a hole in the middle. So that's a negative area, negative version. So we're going to say that was a negative, so we can still do it. And it is done over here by looking at this one over here. We're going to just say pi a4 divided by 4 plus a d squared. We know that is pi r squared over here with the area. So it is division pi multiplied by whatever area it is, which is 1. Radius is 1, right? 1 to the 4, so it's still the same. So it is 4 and pi divided by 4 basically. Plus area, which is pi again, because it's just that, multiplied by 8 squared, which is gonna give you something interesting. Is equal to 201.8 negative, because that's negative. So 62.5 plus 774 plus 1224 minus 201 equals about 1859, which will not round up this time. It's actually just B. It has the exact answer this time. That's shocking. Yeah, a lot of times they don't have the exact answer. That is new. to me. That's often not the case. Now with this, we have moment inertia is about 352 cm. What is the to the y-axis? That's I don't even need to look at it. That is basically the square root of 352 divided by 8, right? Equal that. And we got the area last time as something, right? I remember like 36.5 or something. So second square root of division 352 divided by like what was it again? 36 something, which is about 3 point something. Um, we should probably uh zero point 0.5, right? That's 36. All right, so I get equal to 3.12, which I'm assuming it is B, because that's probably the right answer. I rounded. I could have double checked the area, but I didn't. This is asking for what is at the centroid to x-axis over here. And you ask me, how do you get that? It is basically, first off, you have to get this portion over here, which basically says that we need to get the actually areas first, right? Because the summation of yi, ai, because we're getting the y direction over here, divided by summation ai. So we get the summation ai equals basically 6 times 8 divided by 2. And I would recommend you just immediately put that into your calculator and get a form that's a number, so you don't have to yeah, you don't have to really think about it anymore. And that's 24, okay? And it's gonna be plus, and this is why, 1/2 because of the half being the half a circle, and the square root of 6 squared plus 8 squared divided by 2 square, and then it's gonna be pi. So do that, 1 divided by 2, parentheses division, second square root, 6 square plus 8 square divided by 2, parentheses square, and then we do pi. And then we do enter. We get 39.2699, and that equals to the sum of area. Why I did that is because we need the individuals ones too. So plus 24 on that, and we get 63.269908. We get rid of all the previous stuff over here. We keep the 24 and 39.6 because it's just visually more easier to write about this way. So 24 multiplied by some y1 plus 39.62699 by y2 divided by 63.269908. So with that said, y1 is basically 8 divided by 3 because this thing is a triangle, so divided by 3 we get there. Now here's the thing about the semicircle. We have to get wherever that yi is over here, right? So basically, first of all, we know that it's over here. It's a 3, 4, 5 triangle, by the way. So this is 10, and then this is 5 then. This region over here is 5. But from 5, we need to get the angle to over here, 90 degrees, by the way, to this place over here, which is in this distance over here, is I believe, I did this so many times, I should know it, but I don't. Uh, it is 4a. 4a for 4, so 4 divided by 5, so multiply by 5, 3 pi. So, but we need to get the angle to get to the actual point. So geometrically, what does that really mean? We notice that we know this angle. So if we know this angle, this is 90 minus this angle. And with that said, we have this, so we could do a theta, and this is 90 minus this angle. So why? Because we're using physics. Remember in physics class we did this often? That's how I know it. But in reality, the better way probably is basically do this. I think this way is better. You see how it's like you can make a line over here? This is theta, right? And this theta showcases uh this is theta, right? And with that, with 90 minus that, this is 90 minus theta. And with that said, you can kind of get what I'm trying to get at. Right? This is 90, so this is 90 minus theta. So this must be theta, is what I'm trying to put down. Yeah. And it kind of makes sense on how it is shown. But either way, however you figure it out, you need to use sine and cosine to get this. And this time we need the sine of that to figure it out. We already know that the distance to over here, this distance over here is 5. So we can also use the cosine of that to figure out that one. So 5 cosine. And how do you figure it out? It's a 3, 5 triangle, so it's going to be cosine theta equals what? It's going to be over here, this theta is going to be 5 on the bottom. And if it's cosine, it is 8, so it's 4. And then sine theta is 3 over 5. So in this sense, we can get basically 5 cosine, so 4 over 5, so 4. Let me just do this. Plus, we can do, what is it? Theta again, and this time it is length of 4, 5 divided by 3 pi. It's going to be parentheses by what? It's going to be a sine, so 3 over 5. And whatever that equals. So 4 on, this is going to be 5 multiplied by 4 divided by 5. I know that's 4, but I'm just double checking. I'm just writing in because it's convenient, actually, not really double checking. I mean, like, you double check that in your head, man. Right? Anyways, That's about, I get 5 y2 equals 5.2732. So now we plug in everything. So division 24 multiplied by, once again, 8 divided by 3 plus 3.9, no, not 3.9, 39.62699 multiplied by 5.2732 division 63.2699 equals 4.31. 4.31. Okay, I'm assuming there's a rounding error somewhere, so I'm thinking this is C then, because that's the closest one. Let me check the original answer and see original numbers. I mean, like, and see if there's no, they translated correctly. I guess I made a computational like little bit of a rounding error. All right, therefore that happened. Okay, over here, problem 15 to 60 refers to the cross section over here. The area of moment section is Ix equals 4.7, Iy equal 20, and is respective to the edges. Okay, what is the polar form of the area taken about the intersection? Are we to, I mean, this is just J equal Ix. Is it the edge intersection of Y? Okay, so it's over here. So we're good. It's just Ix plus Iy then. So it's 24 about. Let me just use a calculator to just get the exact number. So it's 4.7 plus 20.9, which is about 25.6. So C, that was an easy one. Over here, what is the x-coordinate of the center of the pyramid like? Okay, so this is basically saying x coordinates. So we're doing x. So it's just doing the summation of xi li divided by li. Li equals 3 plus 0.5 plus, what is this? 3 minus 0.5 is about 2.5. 5 minus 0.5 is plus 4.5, and then it's plus 0.5 plus 5. 5 minus 0.5. Yeah, that's right. Division over here. So 4.5 here. 3 parentheses 1.5 plus 0. Oh, wait. What are we looking for? What are we doing? We're doing x coordinates. So that's 0. So 3 multiplied by 0 because this is what we're looking for. And this is over here. My God, this is going to be a headache. 0.25. I mean, I should show it. This is 0.5 multiplied by 0.25 is probably how I should show it. Plus, where's 2.5? 2.5 is this one, which is 2.5 multiplied by 0.5. Plus, what is next? That's the 4.5 multiplied by wherever that location is, which is 4.5 divided by 2. So 4.5 divided by 2 is there, right? Oh, no. 4.5 divided by 2 plus 0.5. 5, and then plus 0.5 multiplied by 5, and plus 5 multiplied by 5 divided by 2 is 2.5 parentheses. So it's division 0 plus 0.5 multiplied by 0.25 plus 2.5 multiplied by 0.5 plus 4.5 parentheses division 4.5 divided by 2 plus 0.5 parentheses plus 0.5 multiplied by 5 plus 5 multiplied by 2.5 divided by 4.5 equals about 5. What? That is completely nuts. That is totally the wrong answer. So I did something wrong, probably in my multiplication, because let me just check something. So it's 3, 0 in the x direction, right? We're doing x, right? Let me just check. X over here 0 with 0.5, which is then division 2, so 0.25 is correct. This over here is 2.5, which is over here, plus 0.5 is right, plus 4.5. 4.5 is next to 0.5 plus 4.5 divided by 2, yeah, plus 0.5, yeah. Plus 0.5 multiplied by 5 plus 5 multiplied by 2.5. Okay, I think I just multiplied it wrong somewhere. Let's just do the top individually and try to figure out where I did mess up. Yeah, I think I just messed up somewhere. Oh, no. Wait, let me double check all this. 3 plus 0.5 plus 2.5. Did I get something wrong here? No. Okay, so 5 plus 0.5 plus 2.5 plus 4.5 plus this. Okay, 3 plus 0.5 plus 4.5 plus 0.5 plus 5. Okay, I definitely got this thing wrong. Something's wrong about this. Because I think I got a too small of an answer. Because, all right, so it is 0.5 plus 2.5 plus 4.5 plus Another 0.5 plus 5. I get 16. I knew it. This is equal to 16. I don't know how I messed that up. Probably getting tired. And okay, I get 1.48, which is closer, but it doesn't seem to be anywhere near the right answer. So I probably messed up the top now because I messed up that. All right, 0. Yeah, I'm gonna redo the top again. 0 plus 0.5 multiplied by 0.25 plus 2.5 multiplied by 0.5 plus 4.5 parentheses division 4.5 2 plus 0.5 parentheses plus 0.5 multiplied by 5 plus 5 multiplied by 2.5 equals this. This divided by 16 equals 1.8. 1.8, 1.5968, which I'm going to call 1.8. So that is D. My God, that was a little annoying. Six. Okay. With that said, we can now get rid of a lot of stuff and start to think about the moment equations. Yeah, which is an easier way to erase, really. Anyway, with that said, we can now use the moment equation, which is over here. For a rectangle, it is basically this equation on steroids. So it is on the x, so we're creating this one. So bh cubed divided by 12 plus area multiplied by yc minus the displacement they're in squared. So bh cubed divided by 12 again, plus a, this is 2, 2, and b squared h 3, 3 cubed divided by 12 plus a, parentheses yc minus d squared, parentheses yc minus d squared, and you will get the answer from here. So you just have to do this. So division, I know the base for the first one is which one? We're going to do base first. I guess we'll do the five. We'll do the top one first. 9.25 multiplied by h, which is 1.5 cubic. And then we do 12 plus a, which is 9.25 multiplied by 1.5. Parentheses yc is 5.57 minus parentheses 1.5 plus 7.25 plus 1.5 divided by 2 parentheses equals something ridiculous. You forgot the square, man. The square is necessary here. Okay, square. And make sure it's squared properly. Square. So I get 216, which probably is correct. 9, okay. Division over here, next one, second one, we have 4. So 3 multiplied by 1.5, multiplication, multiplied by 7.25, okay. And then that's cubic, divided by 12, plus A, which is 3 multiplied by 1.5 multiplied by 7.25, which is area, multiplied by parentheses, which is basically going to be the center of it. So it's going to be 5.57486 minus what? Uh, parentheses 1.5 plus 7.25 divided by 2, parentheses square, is about 149.506 division. So next one is the bottom one, b is base, so 3 multiplied by 1.5 multiplied by 1.5 cubed, 3 divided by 12, and then plus a, which is 1.5 multiplied by 3, parentheses, 1, what is this? What 5.57486 minus, what is y? 1.5 divided by 2, parentheses, square, equal about 10, wait, did I do something wrong? 10, I think I made a mistake here because I get 1.1, which is not right. Oh, I forgot another. I made a mistake here. 1.5 multiplied by 3 multiplied by 1.5 multiplied by parentheses 5.57486 minus 1.5 divided by 2 parentheses square equals about 590. I get 590, which, okay, I think that's reasonable. 190. Let me double check that although, because I did make a mistake first. So division, I get b base is 1. Oh wait, it's actually 5.5. Oh, that's probably where I got all the mistake. Okay, here's the mistake. So division again, 5.5 multiplied by 1.5 cube divided by 12 plus area is so 5.5 multiplied by 1.5 multiplied by parentheses, and it's going to be 5.5 7,486 minus 1.5 divided by 2 parentheses square equal 193.6. I think that's about right. And now we do this. So we're just going to do 196 or 193 plus 149 plus 216 equal 55558 to round up to 560, which we get B. There we go. All right, the last question here, and this one's also the idea of a negative area comes in again. And it's a very powerful idea. So this is the y coordinate, so you're going to do yc equals summation of yi, ai, divided by summation of ai. What does that equal? Now, basically, we all know what the big circle is. We know what area is too, pretty much. So, summation of ai basically is equal to saying 4, right, times 4 minus this, which is 1 times, my God, this graph is very skewed, but that's what it is. I would say that this graph is so skewed that I think there might be an error. Yeah, there's probably error in this generation. I don't know. 4 multiplied by 4 minus 1 basically is 15. So 15 is on the bottom. And then 16 parentheses is going to be coordinate to 2 basically. And then minus 1 multiplied by where is this thing in the y direction, right? And that's y is a coordinate frame. It is about 3.5, right? Equal division 16 multiplied by 2 minus 3.5 divided by 15 equals 1.9, about C. That is what I get. With that, we're done with this section.